Hi everyone, and welcome back to the fourth video in this series on algebra skills for maths methods. In this video, we'll be focusing on adding together algebraic fractions. I strongly recommend you watch the video or at least read through the notes from multiplying fractions before going through this one, as the material in this section is more difficult. It'll be helpful to know that we can multiply and simplify fractions before proceeding with this video. So please make sure you have a look at that first. So I want to start by reminding you of some things which you hopefully already know about fractions from previous studies. Essentially, if we want to add two fractions together, it's very easy if the denominators are the same. And if you've forgotten what the word denominator means, that's actually just the bottom number in the fraction, and the numerator is the top number. So if I have two fractions with the same denominator, so here the denominator is 15, it's easy to add the two fractions. All I need to do is add the numerators 2 and 9 together to give me 11 on 15. And this step here is often so simple that we usually just skip it. So it's okay for you to skip this step. Okay? However, if the denominators are different, then it creates more work for us because our first step involves converting one or more of the fractions into an equivalent fraction so that the denominators are the same, and then we can add them in the same manner that we did here. So you'll notice the numbers 3 and 5, they're not the same, and I can't multiply 3 by some number to get up to 5. So I'm going to have to convert both fractions. I'm looking for a number that is divisible by both 3 and 5, and I want that number to be as small as possible. And that number is 15. So I'm going to convert 2/3 by multiplying by 5 on top and on the bottom. I'm allowed to do that because I'm just converting to an equivalent fraction. In the last video, we simplified by crossing out the 5s. But I can multiply by whatever numbers I like on top and the bottom as long as they are the same, and that will give me a fraction with the same value. Okay, so I have to multiply 3 by 5 to get to 15. And similarly, I need to multiply by 5. I need to multiply 5 by 3 to get to 15. So now this is going to change to 10 over 15 plus 3 over 15. And now I'm in a situation where the fractions have the same denominator, and now I can write 13 over 15. It's not easy. It takes most people a few years to get to this point where they can add 2/3 and 1/5 together. And now we're adding another layer on top, which involves using letters or pronumerals in the fractions. The idea is exactly the same, and sometimes it's actually easier because we don't need to go searching for a number on the bottom. We just need to multiply the two letters together. So we'll see this. Okay, so let's start with cases where the pronumeral is on top. So in every question that we're dealing with today, I'm giving you two fractions. I'm adding or subtracting them together, and the goal is to write them as one fraction, and ideally as simple as possible as well. So here, 2 and 3, it's not the same denominator, so I'm going to need to convert them to an equivalent fraction with the same denominator. And the sort of obvious number to choose is 6, because 2 times 3 is 6, and there's no number smaller than 6, which is divisible by both 2 and 3. So I'm going to change x on 2 to x on 2, x times 3 divided by 2 times 3, and x on 3 to x times 2 divided by 3 times 2. This is going to give me 3x on 6 plus 2x on 6. And now I can add the numerators together. So this is going to give me 3x plus 2x divided by 6. Here I'm using the first property. If the denominators are the same, I can add the numerators together while keeping the denominator the same. And that simplifies to 5x on 6. Now, as you grow more confidence, you can show just these steps. The other steps you can skip once you are feeling confident. They're not necessary, but the reason why I'm showing you more steps is to make it really clear, essentially, what's happening. Okay? All right, so we'll do another one. I've got to create a bit more space because this is taking a bit more than I was expecting. Okay, so same idea here. The numbers are a little bit bigger. First, I'm seeing that the denominators are different, so I will need to convert one or more fractions. I'm looking for a number that is divisible by both 4 and 5. The smallest number that's possible is 20. So here, I'm going to convert 4 to 20 by multiplying by 5. If I do that on the bottom, I need to do that on top as well. Now here we are minusing. It's not adding, so it's essentially the same. Convert the fraction and then minus instead of plus on top. Now to convert 5 to 20, I need to multiply by 4. If I do it on the bottom, I have to do it on the top as well. So now I've got 3x on 5 over 4 times 5 and 2x on 2x times 4 over 5 times 4. So now we can simplify. This gives us 15x over 20 minus 8x over 20. Now, to subtract two fractions with the same denominator, all you need to do is subtract the numerators while keeping the denominator the same. And now I can collect like terms. So 15x minus 8x gives me 7x. The steps you should show at a minimum are these two steps. Okay, let's keep going. Now, this question is going to involve two negative signs. We'll have to deal with that. Have to think about what's going to happen there. We don't actually need to do 2 times 6 to get 12 here. Because if I ask the question, what is the smallest number that is divisible by both 2 and 6, the answer is actually 6, because 2 goes into 6. So I just need to multiply the first fraction by 3 on top and 3 on the bottom, and I can actually keep the second fraction exactly the same. So I'm going to have 3 bracket x minus 1 over 6 minus 2x minus 3 on 6. Okay. Our goal is to have one fraction, so we need to combine them. So 3 bracket x minus 1. Now I want you to note that we are subtracting the entire fraction here. So I need to write minus bracket 2x minus 3. I'm not just subtracting 2x, I am also subtracting negative 3. Okay, and now I can expand the brackets. So 3 times x is 3x. 3 times negative 1 is minus 3. Minus 2x. And then minus 1 times minus 3 gives me plus 3. So make sure you don't drop the positive sign here. Please be very careful of negative signs. Okay, 3x minus 2x gives me x. Negative 3 plus 3 gives me 0. So my answer is just x on 6. The steps which I think you should show are this one, this one. I recommend showing this one as well. So you should show most of these steps in your working, even if you're confident, because it's very easy to make an error here with negative signs. Okay, let's keep going. So here I've got two fractions, 1 on x plus 1 over x cubed. You'll notice there's no numbers in the denominator here. So that actually makes it easier. You don't need to look for a number that goes into both numbers. But I still need an expression involving x that's going to be divisible by both x and x cubed. The sort of obvious one to choose is x cubed. So to change x to x cubed via multiplication, what I need to do is multiply by x squared. Okay, because x to the power of 1 times x to the power of 2 is x to the power of 1 plus 2, which is x to the power of 3. Okay, this is going to simplify to x squared over x cubed plus 1 over x cubed. And now I use the first property on the very first page. If the denominators are the same, I add the numerators while keeping the denominator the same. And I recommend you show these two steps. Now, when we got to this final answer here, we actually can't simplify any further. We're actually done. So sometimes these questions are shorter when your denominator just involves pronumerals. Okay, I think I've got one more question and then we're leaving it there for today. Yep, that's it. Okay, I'm actually going to change this to a minus sign just to give us a bit of practice with negatives. So right now this looks like a mess. I've got two fractions and it's not just x on its own, it's x with something done to it, like minus 2 or plus 6. But think about what you would do. The only way for me to get a denominator that works for both is to have x minus 2 times x plus 6 on the bottom for both. So often if you have two denominators, which are algebraic, you'll just need to multiply them together to get them compatible for addition or subtraction. So here, what I've done is I've multiplied both the top and the bottom by x plus 6 for the first fraction. And then for the second fraction, just make a bit more room so that you can see it, because I think my face will block this. And the second fraction is 7 over x plus 6. And now I want to multiply by the other factor, which was x minus 2. Okay, it looks messy, but let's combine some stuff. So first I'll just rewrite this with brackets. 3 brackets x plus 6 over x minus 2 x plus 6 minus 7 bracket x minus 2 divided by x plus 6 x minus 2. And one thing I want you to know is that even though the order is different here, when I multiply two numbers, it's the same. So the denominators are actually the same here, even though the factors are written in a different order. So because of that, I can now use the same property, 3 bracket x plus 6 minus whatever is in the second fraction, 7 bracket x minus 2, and all that divided by the common denominator, x minus 2, x plus 6. Okay, now, so in a question, you'd be told whether to expand at this point. I think we can simplify the numerator by collecting like terms. So let's do that. So we're going to have 3 times x plus 3 times 6 minus 7 times x minus 7 times minus 2, which gives me plus 14 because there are two negative signs here. So again, please be careful not to drop the plus sign there. Okay, 3x minus 7x gives me negative 4x, and 18 plus 14 gives me 32. And that's it. Now we can't simplify any further. Okay, so negative 4x plus 32 divided by x minus 2, x plus 6. Which steps should you show? I think you should show at a minimum so do we need this step here? Probably not, because the denominator is the same. We know that. So yeah, please make sure you show at least these 3 steps in your working. I'd say either this step or this step, and then show both the purple ones. Okay, so that's a wrap up of algebraic fractions. The only way to get better at a new skill is to practice. Suppose you wanted to learn to play the piano. It's one thing to watch someone play the piano, to watch them talk about playing the piano, but at some point you've got to sit on the stool, get your hands and play the keys. If the piano analogy doesn't work for you, pick a sport or something that you like. Practice is how you get better at anything, and that includes maths as well. So I'll let you have a go now at some exercises. Thanks.